Hello everyone, in today's video we will go through Airdrop and Lazy Mint. We'll be using Opensea workshop contracts. We'll build production code on top of it. So now we want to show you the contracts.
Yeah, so here's the workshop repository. Is the workshop number 6, and here we have a few contracts that are useful when creating airdrops. So those are industry standard contracts, so nice to use, and there are a few versions we can choose from. So Merkle drop, Lazy Mint with various versions, and basic contract, and a smart wallet contract. It's a separate thing, really. So to determine which version we want to use, we went through all of the options, and we decided that we don't want to use Merkle drop because if we decide on the airdrop list, like who gets which tokens, and we deploy the initial airdrop, then we won't be able to mint new tokens and share them with other users. And we want to be able to mint new tokens for other users later on. So it means that we are left with 4 other contracts, and in our case we want to use Lazy Mint because we want to share money on gas, so that we don't cover, we as contract owners, as deployers, we don't have to pay for all the minting, and it's very expensive, especially if you mint out of tokens. But we create a signature, and then the consumer, so somebody who receives the NFT through the airdrop, has to mint it and pay the gas fees. So everybody pays for himself. And for sure we want to use a 712 option. We want to use this protocol, but we have 2 versions here left, so 712 or 712 with signature tracker. The difference is pretty small. When you open both contracts, the first thing that stands out is the difference of elliptic library or the signature tracker library. And actually the signature tracker thing, the library here, as you can see, it's available in Opensea contracts. It's a wrapper that has only one function, and it identifies what type of wallet it deals with. If, as said in the description here, in the comment, if it's a smart contract, so if it's a smart wallet, like the one we will use in here, then it uses a custom function, and it uses ERC1271. But if it's a regular wallet, then it uses the recover from elliptic, and just like in this case. So it verifies contracts in a different way. In the advanced version of the contract, you have to pass another argument here, which is signer, and signer would be the smart wallet contract. So let's use the bit more advanced version and implement the airdrop this way.
Now we are in Remix. It's our main contract. It's for lazy minting. And here you can see that the admin role, so like the owner of the contract will be us because it's from message sender. Also we can call by ourselves the minter role because it's not called yet. Also the main function redeem will mint our tokens, but first we need to fulfill the requirements for the signature. And the last important thing here we want to mention is for the base URI, a little down, right? And here we can set our URI from the IPFS, but first we need to access Pinata, so we have to go for the Pinata. Okay, time for upload. We'll choose the folder. Yes, and our metadata for Pinata. Let's try to upload. It may take a while. Let's reload because it didn't appear yet.
Yeah, so maybe we could reuse already existing folder with all of the metadata. This looks like Pinata is down.
Yes, right. Something is going right, going wrong. So we can use that. Let's go back to Remix and just copy paste that.
Yeah, it was the same.
Yeah, it was the same. Okay, great. So it's the first contract, and the other contract we will need will be Smart Wallet. So we can just pick a little on it.
Yeah, but we could also mention the structure of the Pinata folder. What do you think?
Yeah, might be useful. So it's the JSON object compatible with, for example, Opensea, where we can connect a lot of information like the images, description, and so on for our token. And we can pack it up in the Pinata. So then we can add another token by incrementing it. When we try to mint one, the increment happens, and then we have another token IDs, and we can create the next feature tokens.
Yeah, so it's a standard compatible with, for example, Opensea. And each file needs to not end with .json, just a file name without the extension here. And it will be working automatically whenever you mint a new token, if there is a corresponding file here.
Yes, that's right. So now we can just pick at Smart Wallet. Yes, so it will be our signature for our contract. And to make it right, we first need to deploy that contract. So we can go to the deployment section. And we have to choose our contract, of course. So now we want to pass an argument as our address. We'll go to MetaMask and use our own. So copy paste that and just do the transact. Okay, great, it's published. And now we can go for our second contract. Great, and again, same thing. So here, yeah, we have to pass just the names.
And deploying on Rinkibi. But we were missing funds, so let's try again. But yeah, the balance is pretty low, so we need to charge the account up. So I use faucet.
Very quick and good solution for earning test money.
Yeah, there's an official faucet, but it seems to never be working. Like, so we always default to this one.
If you have problem with that, we'll leave the link in the description. Okay, let's confirm that. And here we are, ready for HTTP script. So we can move to Visual Studio Code.
Yeah, or maybe first just let's grant a role, so
Yeah,
we will be done with this
okay.
remix for a while.
So as we mentioned before, we want our admin to have minter role, so we can access here the minter role, and we'll copy paste that, and we'll choose the account.
Yeah, so it will be the smart wallet.
Yes, exactly, because we want
Address.
smart wallet to become the minter, because we'll use him as signature. So that's the point.
Correct data. So yeah, okay, looks like role is off. Okay. I think we can let it process. Oh, okay. It's completed, so we can move to our web page. Very simplified script, which you can use. You can set up without major web frameworks. You don't have to use any React stuff here, or you can just use only one file and live with it and test and see what happens. So it doesn't require a lot of boilerplate. But to show you how it works, I'll just fold all here, and we start in head section, and we need a few scripts. We need jQuery, we need Web3, Moralis, and Eaters to work with our contracts, to operate on files, and displaying error messages. Then in our body, the first thing that you can see is our widgets. We have two very simple buttons. It's sign button for signing signatures, and load button, which we use for checking NFTs owned by our account or provided any other address. Then we have our actual script, and we start with some data at the top. It's our airdrop whitelist, so we provide a list of objects with token ID and address, a MetaMask address that's gonna receive the given token ID, so the given NFT. We can extend the list. We can start with 1 and 2 because the token IDs usually start with 1, and it's incremented to the infinity. Then we need to provide collection address and smart wallet address. So those things we can copy from Remix. Yep. Then we have two variables created but not initialized yet, so that we have easier access in other functions. Then we have a function, we have a snippet here that connects to our MetaMask. But as you can see, we use the window Ethereum version. It's the newer version, and the legacy API, which is window Web 3. Differs by only one line of code here, and then it defaults to the same function, which is init app. Init application goes through a few inits, so we init all of the libraries we work with, and so Eaters and Moralis, and we init our sign and load buttons. So init Eaters is very simple, just creating a new provider and signer and assigning them to our variables. We use this to work with MetaMask. We have init morales, which we'll use for reading data from blockchain. So, like I said before, for example, checking all of the NFTs assigned to my MetaMask account, to my wallet. And what we need to provide here is data that you get when you register on Morales. You create a new server and select Rinkibi, because in this guide we're working exclusively on Rinkibi, which is an Ethereum testnet. So when you register, you have both server URL and app ID, and you pass them here. When you execute Morales start, the Morales application starts, and you're ready to use all of the provided functions. So now we are left with init sign button, load NFTs button, and download file, which is less important, but more on that later. So we register clicks. We have a listener for listening on clicks on our sign button. When you click on our sign button, we have the sign all tokens function, which will make sure that we are connected to our MetaMask account. And then it iterates through all of the tokens that we provided at the top. So it goes through them all. It signs a signature for each of them, and pushes all of the results to our token objects array, which will be stringified and saved to our generated tokens, and we'll store all of the airdrop info in our generated tokens JSON file. We're back. I had a call from Donald Trump. He said we're doing a tremendous job, and if you want to watch more videos like that, you can subscribe to our channel. And now, speaking of the sign function, which is basically the core of this video, how it works, we need to provide domain types and value information and pass it to our sign type data function. How it works, it triggers a MetaMask pop-up with all of the disclosed information about token ID, address, domain information, and then when the user accepts, signs the signature, the code will go through and it will return the full object with all of the information about the current token ID, of course, and its signature, smart wallet address, so it's signer, and address of the person is supposed to go to. So this lock was used for development purposes. You can leave it if something wrong happens, but we don't need it here now. And types is basically an ABI format that we use. So we have an NFT that requires token ID and account. We specify the types here, and then we provide both values according to those types. So it's token ID and address. We pass here from the previous function. So again, it's all this information. So then eventually we iterate through all of the items, and we end up having the content. So it's information about all of the tokens, but summarized in one JSON. And then we use another function, download file, which basically saves a new file, generated tokens.json, with all of the content we created. So this function copied from Stack Overflow Like basically any function that copies the file and save it on your storage is alright. And that's it from signing. Then we are left only with load NFTs button. So again, we register clicks. We get all of the user NFTs using Morales. So we use user address for that. We don't need this lock really. And we specify options. We say that we want to track ringkeepy, and we provide the user address, and then we use the get NFTs function from the account directory. That's important to remember about this directory too. And what this function does, it returns all of the NFTs that belong to the specified address on the specified chain. Another function we have here is get NFT token metadata, and it returns metadata for only one NFT. So we provide token ID, we provide collection address, and that's all we need to put here. And the function will return single metadata of a given NFT. So that's it. If you want to create a visual presentation of all of the NFTs after the user redeems them, you could create a website with all of the tiles and present the NFTs in a nice way. We decided to cut it short here because it's mostly about signatures, and we just console log it to print it in the console. So that's everything in this script. So now we can run it, saving it first. And to run the script, you can use a plugin, which is a live server plugin. And we use a new action, open with live server, because we could also just open the HTML file on in the browser directly without using the server, so without the address and the port. But you would only get frustrated because the MetaMask wouldn't work. We need to operate on a live server, even a local one, to work with MetaMask. Otherwise, you'll get errors like please install MetaMask or similar ones. So now we are live here. We can sign all of the NFTs. So we click on the sign button. We have the pop-up with all of the disclosed information. We are making sure that we are still on the same account we used before. In my case, development 1. And when you click sign, it will just iterate and go through the whole list of objects we provided before. So we are creating a signature for another account for a new token with this ID. And when you click sign, the contract will want us to save the generated tokens file. In my case, it's generated tokens 4, so I'll just replace the generated tokens. And then we can go back to Visual Studio and see that here we have all of the information printed out. But we could use another action, which is format JSON, to have it look better, easier to operate on. And now, as we have all the information, we can execute it in Remix on our contract, so we can redeem all of the tokens now as a customer. So copying address, so it's the person who gets the NFT. Copying signature, copying signer, and token ID, which was 1, and making sure that we are on the privileged account that's supposed to get the NFT. In my case, it's this one. It's 0x320. So it should be the same address as here. And now click transact. And the token will be shortly minted. And again, we used Pinata with all of the metadata information. So now we could just copy the address and present it on Opensea. So pasting it here.
Yeah, and we can see that we can find any, but we have to go for the testnet, yes, because we use string. And we can search by the tokens. So in the link you can see that after the slash there is a 1, and it means that's the token ID. So that's how we can search through all of our minted tokens. If we prepare a few more, then we'll do /1, /2, /3, and so on.
Yeah, so currently if we use /1, it doesn't work. But if we signed 2 tokens, so if we use...
Yes, because we already created one.
Yeah, let's redeem another one, which is created for the same account. So we change token ID in and signature. And soon when the transaction goes through, the counters will create a token ID number 2.
About the picture, we have to wait a little because it's IPFS and it has to load first. It takes time. Okay, so we waited a little, and now we can see the picture is already prepared. So now everything is ready. What I can say that in the next video we'll go through market drop, and if you'd like to see it and enjoy our content, just subscribe, the button under the video, and thank you guys for your time. See you next time.
Yeah, thanks to you.